Okay, hi everyone. In this video, we are going to learn some basics about fractions, some terminologies, also some basic operations. And in the end, we are going to learn how to compare two fractions. So we have 6 learning objectives here. Let's go through these objectives one by one. First, let's learn some very basics about a fraction. First, the names of the different parts in the fraction. And basically, a fraction is written as 2 whole numbers. One is on top, one is on the bottom. In between, there's a bar. And the number on the top, I call it numerator. And it is also called multiplier. And the number on the bottom, it is called denominator. And it is also called divisor. Later on, it's going to be very useful. We multiply by multipliers. We divide by divisors. Makes sense, right? But that's for later. And this bar in between, apparently, is called a fraction bar. And it is also called division bar. Yep. Different parts in the fraction. Now, our next terminology is called proper fraction. So what is a proper fraction? When the number on the top is smaller than the number on the bottom, it is called a proper fraction. When we talk being bigger or smaller, we refer to the absolute value. We only look at the size of number. In other words, you could have a negative proper fraction and positive proper fraction. We just compare the pure numbers. If the number on the top is smaller than the number on the bottom, we call it a proper fraction. Now, improper fraction, and this is also 2 numbers. If the absolute value means we only look at numbers, we ignore the sign, okay? If the number on the top is equal to or greater than the number on the bottom, in either case, it is called a improper fraction. Let me give you an example. So this is the example of proper fraction. The number on the top is smaller than the number on the bottom. And this is also proper fraction. The number on the top is smaller than the number on the bottom. We are talking about absolute value, we ignore the sign. Okay. And how about this? This is an example of improper fraction, because improper fraction, by this definition, has 2 different scenarios. One is the number on the top equal to the number on the bottom. The other one is the number on the top is bigger than the number on the bottom, and regardless the sign. Okay, these are the examples of improper fractions. Okay. Now move on to the next page. Now this is a visual representation of a proper fraction. Let me mention this. So 1, 2, 3, 4, 5. So this whole thing is divided into 5 equal slices, right? And that is the meaning of the number on the bottom. In other words, the number on the bottom represents the whole thing. Represent one whole, whatever that whole is. Could be one whole pizza, could be one, say, total number of students in one classroom. Could be anything. That's one whole thing. You divide that one whole thing into 5 equal parts. In other words, in the fraction, the denominator represents the whole thing. Now the shaded area is 3 out of 5. So this is 3. This is a proper fraction. Apparently, this is smaller than 1, right? Because 3 is smaller than 5. 5 represents the whole thing. This is a part of the whole thing. That's why we call it a proper fraction, because we mean part of whole thing when we say a fraction. So that's why we call it proper fraction. Now, let's look at some specific examples. Name the fraction represented by the shaded area. We have two of this. We do this one by one. And first, no matter how many parts it divided into, this is the one whole thing. Okay, in this case, say let's see how many small squares. 1, 2, 3, 1, 2, 3, 4, 5. So we have 3 rows. Each row has 5. So totally 15 small squares. This whole thing is divided into 15 equal parts. How many parts are in the shaded area? 1, 2, 3, 4, 5, 6, 7. So that's a 7 out of 15. 1, 2, yeah, 7. Okay. And this is a proper fraction. How about this one? This whole circle is divided into 8 equal parts. And the shaded area is 3 out of 8. So this is another proper fraction example. Now, here is your first set of question. You have 2. And name the fraction. Just write the fraction according to the graphs. And the answer to all of the exercise problems in my video is in the comment area below the video. Now, let's look at our second example. In a group of 35 people at a conference, 17 are wearing glasses. What fraction of the people at the conference are wearing glasses? We are talking about 17 out of 35. And the total number of people attending the conference is 35. So the 35 represent the whole thing. That is our whole thing. Out of whole thing, 17 wear glasses. So we put 17 on the top. So this fraction represents a portion of people who are wearing glasses. So this is the answer to the first question. And we have a second question here. What fraction of the people attending the conference are not wearing glasses? We are talking about the rest of those 35 people, right? So 35 minus 17, that's 18. So we know 18 people are not wearing glasses, but we want to have a fraction to represent this 18. So 18 is 18 out of 35. So this fraction of the total number of people who attending the conference are not wearing glasses. I think I make it clear. Now let's move on to the next one. Now your exercise questions, 3 of those this time. Yeah. And our next learning objective, we are going to learn how to write an improper fraction as a mixed number. So here are some examples of improper fraction. Remember, an improper fraction is a fraction where the number on the top either equals the number on the bottom or bigger than the number on the bottom. Simplify, we just write it in the simpler form. This is 1. Anything divided by itself is 1. Remember, this fraction bar is also called division bar. 5 divided by 1 is 5, but we have negative sign in the front. So this is negative 5. We cannot divide by 0. So basically, this is undefined. You cannot do it. Yeah, that's it. Very straightforward. Now, the third one, very similar exercise problems. You have 4 of these improper fractions. Now, let's look at how we convert an improper fraction to mixed number next. But I have an example of improper fraction 9/4. What does this mean, really? So basically, the number I just mentioned a moment ago, the number on the bottom denominator represents the whole thing. You just divide the whole thing into 4 equal parts. Now, what does the number on the top mean? You are considering 9 of those parts. When you divide a whole thing into 4 equal parts, and you have 4 equal parts, one part, right? And we are considering 9 parts. You may say, hey, how can we have 9 parts if the whole thing is 4 parts, right? That's the exact meaning of improper fraction. It's improper, and it means more than one whole thing. It's just a matter of how many whole thing. Okay. Now let's look at how we convert a improper fraction to mixed number and make sense. Okay, now I'm going to rewrite this as 9/4. 9 equals 4 plus 4 plus 1. Is that right, everyone? So the basically is 4 over 4 plus 4 over 4 plus 4 over 1. Remember, this number on the bottom represents the whole thing. You take whole thing out of whole thing, you take whole 1. This is 1, this is 1, this is 1/4. So you get 2 1/4. That's how we write a mixed number. A mixed number is just combination of whole number and a proper fraction. They say integer because we could have a negative mixed number, negative whole number. Okay, just a whole number. So a whole number and a proper fraction. Now let's look at more example how we convert an improper fraction to mixed number. So this is just for the explanation purpose. When you actually convert a improper fraction to mixed number, you don't do it this way. Imagine if this number really big, you're gonna write many fours. It's just not efficient way to do that. Instead, we want to know how many this number, in this case 4, are in the number 9. In this case, there are 2 4s in the 9. So there's 1 4, another 4. That's why you have 2 as a whole. Each 4 in 9 give you 1 whole because 1 whole is divided into 4 parts. So in other words, we just need to do division. Division tells us how many of the second number, which is divisor, are in the first number. In other words, does it make sense to you? 10 divided by 2 equal to 5. What does this mean? This means there are 5 2s in 10. That's the meaning of it. So whenever we do a division, we want to know how many of the second number are in the first number. And that's why we want to do division, because each 4 gives us whole 1. We want to know how many 4s are in 9. That's why we use 9 divided by 4 to convert it to the mixed number. So if I do division, it goes like this. We know there are 2 4s in 9. 2 times 4 is 8, and remainder is 1, right? They just tell you whole number part. The quotient is your whole number part, okay? You have 2 whole 4s in 9, and remainder is 1. Put remainder as on the top as a numerator, and put the 4 on the bottom. That's how we write a mixed number. Okay, now let's look at some examples. Write the improper fraction as a mixed number. So we just do division. We already know that, right? So 20, actually this simple number, probably you already know the answer, but this is the formal process. Divided by 3, we get 6, that's 18, remainder is 2. So this equals 6 and 2/3. Always put divisor on the bottom. And the other one is a negative number. We will get a negative number. We just change the improper fraction format to mixed number format. We don't want to change the value, right? That's why we just carry this negative sign over. We do division using 41 divided by 7. 6 times 7, everybody learned multiplication table, right? 6 times 7 is 42, it's too big. So that's 5. 5 times 7 is 35. Remainder is 6. Now our answer is 5, and put this divisor on the bottom. remainder on the top. Almost negative 6. That's why we want to convert improper fraction to mixed number. It's easier to identify how big, how small it is. Very close to -6, right? Just 1/7 away. Now, here is another set of exercise problems. Practice is important in learning mathematics. Now, let's look at our next example, example 5. Divide and write the quotient as a mixed number. So basically, just do division. It's equivalent to put this number on top, this number on the bottom. It's equivalent to this. We already know negative divided by negative. We learned that in the whole number chapter, in the first chapter. And whole number negative divided by negative is positive. So we just need to do division. 2035 divided by 19. So when we do division, actually we want to know how many of this number are in this number, right? Actually, we look at this digit by digit. Is there 19 in 2? No, there's no 19 in 2. That's why we don't put anything above 2. Is there 19 in 20? Yes, there's 119 in 20. So put 1 above 0. Remainder is 1. Put down another digit. Is there 19 in 13? No, 0. 0, 19. Put down another digit. How many 19? We need to try. If we got, say, 5 19, that's 9. This carry is 4, that's 9. 95. 95 is far away from 135. So that means that 5 is too small. Maybe we try 6. Let's say 6 is, let's try 8. See what we get. 8, 9, 72, 7, 15. It's too big. Let's try 6. 6, 114. 114. Imagine your remainder is 21, still bigger than that. So 7 is the right number. But you can use a calculator to try. So 7 times 9, 63, carry 6. 1 times 7, 7 plus 6, 13. So remainder is 2. So the answer is negative divided by negative is positive, right? 107, 19 on the bottom, 2 on the top. Yeah. There are more than 107 19s in this number. And this is your exercise. Nothing different. It's just write the division in horizontal manner instead of in the fraction format. Now we want to do the opposite operation. This time we want to convert from a mixed number to an improper fraction. We just convert from improper fraction to mixed number, right? We want to reverse it. So this one, we already did this. This one equals 2 and 1/4. How we get 2? We use 9 divided by 4, right? So we want to reverse this process. Since this time, we want to convert a mixed number back into improper fraction. How to reverse that? We do opposite operation. When we divide by 4, we get 2. Now we want to go back. That's why we multiply these two together. Multiply. Then after we multiply, we get 8. Then add this numerator. 4 times 2, add 1. Multiply, add. Multiply, add. So we get 9 over 4. We don't change the denominator. This is how we get 2 in the first place, by dividing by 4. So we don't change the denominator. So very simple process. Multiply, add. Now let's look at our example 6. So if you want to read the formal process description here, here's a description. But I'd rather do things in a more visual way. Multiply and add. Write the mixed number as an improper fraction. So let's do that. Keep 8 on the bottom. 8 times 5 plus 7, right? Multiply 8 is 47. That's 47 over 8. Now, next one, this is negative number. This is not negative 9. You are not going to use 7 times negative 9 plus 3. If you do it that way, you only treat this negative sign as part of 9, not part of the whole thing. This whole thing is negative, including this negative 3/7. Basically, this means negative 9 plus negative 3/7. It's not negative 9 and 3/7. So that's why you cannot multiply by negative 9. We just carry over this negative sign. But still do the same thing. 7 times 9 plus 3. Multiply 8. 7 times 9, 63, plus 3, 66. So we got negative 66 over 7. Now, finish it. And here's another set of exercise problems. Now, new topic here. What is a rational number? Here's the definition. A rational number is a number that can be written as a fraction. Ratio of integers means fraction. And here are some examples of rational number. This one is already in fraction format, so this is rational number. This is also fraction format. It's a rational number. Fraction format means you can write it as something look like this, a over b. Okay, sure, we can convert this one to improper fraction, then it looks like this. How about whole number? This can be written as negative 7 over 1. That's rational number. How about decimals? Even though we don't learn how to convert decimal to a fraction today, but example say 0.375. If you use a calculator, convert it to fraction is 3/8. In other words, most of the decimals, not all of those, can be converted to an exact fraction. They're also rational numbers. I just mentioned it here so that later on we can talk about this in detail, but not today. But these are the examples in this section that are rational numbers. Now, here's another objective: graph fractions or mixed numbers on the number line. We know how to graph a whole number already in the whole number chapter, right? Now let's see how we graph a fraction, including negative fraction. But we do this number, we do this one by one. The first 1/4. First 1/4 is smaller than 1, right? Proper fraction, but it's positive number between 0 and positive 1. Let's suppose this is our 0. Okay, this is just number line. You can designate any point as 0. Now here's I need 1. Where do I put 1? Depend on this number. Remember, fraction, the meaning of the denominator. Denominator represents the whole 1 divided into this many parts. So 1, 2, 3, 4. So if I call this point as 1, where's 1/4? Divide the whole thing into 4 parts. But the one part is 1/4. We're talking about this point. This point is 1/4. One quarter of the whole thing, whole unit. Okay, we move on to the next one. We get negative 5/8. First of all, 5/8 is 1, is smaller than 1. So this negative 5/8 is between 0 and negative 1, because negative 1 means negative 8/8. So again, we designate a point as 0, so we call it 0. Negative 1, this time we need 8 units to represent one whole, right? So 1, 2, 3, 4, 5, 6, 7, 8. Here is negative 1. Negative 1. And to the left, we get negative numbers on the number line. To the right, we get positive numbers. Now we just need 5 units starting from 0 to the left. 1, 2, 3, 4, 5. This point is our negative 5/8. Yep. This point. You don't need to draw this arrow. If you have homework similar to this one, I just pointing to this one. This point, not this point, is our answer for the negative 5/8. And the last one, we want to draw a graph negative 3 and 5/8. So apparently this is the between 0 and negative 4, right? You can say between negative 3 and negative 4 because this is negative 3 and something, between negative 3 and negative 4. So I just designate this point as negative 3. We don't start with 0 because start with 0, we need 24 to account for 3. That we don't have that many units, right? This is negative 3 versus negative 4, 8 units to represent the whole one. 1, 2, 3, 4, 5, 6, 7, 8. This point is negative 4. Now we have 8 units in between. We need 5 units. This is 1 unit. We need 5 out of this one whole. 1, 2, 3, 4, 5. This is our point. This is negative 3 and 5/8. This is how we graph fractions. Hopefully this makes sense to you. Let's move on. Write equivalent fractions. What are the equivalent fractions? Equivalent fractions that have they have same value, but they have different numbers in the numerator and denominator, but they have same value. Pretty much like this one's illustrated here using pizza, right? So this is identical pizza. This is 1/2 of pizza because it divides whole pizza into 2 equal parts. You get 1 part. That's 1 out of 2. But if you divide the same pizza, identical pizza, same pizza into 4 equal parts, you take 2 parts, 2 out of 4, visually now this is the same thing. It's equivalent to half pizza. And another equivalent fraction is that if you divide the same pizza into 8 equal parts, you take 4 parts, you still get half pizza. These are called equivalent fractions. They are equal in value, but have different numbers. But how do we write equivalent fraction? They're all equivalent. Okay, you can make a fraction into bigger numbers, which is still equivalent, or you can reduce a fraction to smaller numbers to get not equivalent fraction. You can go either direction, depending on what you need, basically. So how do we do conversion then? You either multiply both sides, numerator and denominator by the same number to make it bigger, or you divide both numbers by the same number to make it smaller. Either way is okay, as long as you do the same number on both sides. So let's look at some examples here. It says fill in the blank so that the fractions are equivalent. Now actually it's pretty easy to do. We go in this direction because we need to figure this question mark. Look at the other side. From 8 to 16 is double, right? Multiply by 2. You have to do the same thing on both sides. 2 times 3, 6. So the answer is 6/16. Why we have to multiply or divide both sides by the same number? Look at these two numbers. 2 over 2. 2 over 2 is 1. When you multiply by 1, you don't change the value, right? You change the numbers, you don't change the value. That's why we have to do the same number on both sides. Now look at the other one. We want to find this question mark in this direction, right? If you look at the number on top, it's getting smaller. So this has to get smaller by the same factor. 20 divided by 4 to get 5. This one has to divide by 4 to get a question mark, right? So 24 divided by 4, 6. The answer is 5/6. Now, one number is getting bigger. How do we know which number to divide to get this number? Actually, just use the 20 divided by this 5. to get the number you divide by. See my point? It's very easy to do actually. If number getting bigger, you don't know which one number divided by to get that. Divide that first to get that number you divide by. You need to divide by. Then using this number, divide by the same number. Exercise, more exercise, right? Let's look at the next page. This time we want to compare. This is the last learning objective. Compare between two fractions. First of all, this is an easy one. Look at this fraction. We already know, by the way, we need to recognize this comparison symbols. This is read as smaller than. We read this from left to the right, okay, smaller than. What this means is that we use the opening of the symbol always face the bigger number. For example, we read this one as 3 is smaller than 4. 3 is smaller than 4. We read it from left to the right. But if you put 4 as the first number, 3 as second number, you know 4 is bigger than 3, right? Remember, when we use these symbols, the opening always face the bigger number. That's why we write it this way. 4 is bigger than 3. Okay, we already know 2/5 is smaller than, hold on. 2/5 is smaller than 3/5, right? This is from common sense. But let's visualize this so that when we have more bigger numbers or complex numbers here, we can still compare them. So remember, the number on the bottom represents the whole thing. You just divide that whole thing into this many parts. So this is the whole thing. This is our whole thing. We divide it into 5 equal parts. What is 2/5? Let me get a marker here. This represents 2/5. This yellow part. 2/5. So what is 3/5? This is 3/5. This is the same whole thing, okay? Apparently, this yellow bar is smaller or shorter than this yellow bar, right? So 2/5 is smaller than 3/5. It's common sense. Now let's look at our next one. Remember, this is the one that is easy to compare, is because we have the same denominator. You divide the whole thing into same equal number of parts. Sure, you only need to compare the other side. Easy to compare. Now let's look at the next one. And between 1/2, 1/2, and 1/3, again, from common sense, we know 1/2 is bigger than 1/3. But let's visualize that first. This whole thing divided into 2 equal parts. 1/2 means 1 part, right? So this is a half. Now, what is 1/3? You divide the same whole thing into 3 equal parts, and you get 1 part. Apparently, 1/2 is bigger than 1/3. But there's a potential issue here. What if you have bigger numbers? They're all different on the bottom, double digit, different numbers. And even more, furthermore, if you have different number on the top, also not both have same number. How do you compare, right? Actually, there's an easier way to compare these two. Let's use this two as an example. There's easier way to compare that, because we already know everybody can compare these two, right? Why? Because denominators are the same. Whichever is bigger on top, that number is bigger. It's easier to do. So for that reason, I want to visualize these two fractions so that they have same number on the bottom. How do you get that number? We use common multiple. Common multiple of 2 and 3 is 6. So I divide whole thing into 6 parts. Here it is. I divide this whole thing into 6 parts. 1/2 means half of it. Half means 3. 3 out of 6. That's half. Everybody can see that? Actually, literally, it's half. If you look at this part, what's this part? They're identical. This is half. But in terms of dividing into 6 equal parts, you got 3 parts, 3 out of 6. That's equivalent to, this half is equivalent to 3 out of 6. Both represent same thing. Now, what is the 1/3? If you divide this whole thing into 6 equal parts, this is 1 out of 3, right? This 2 represent 1 out of 3 equal parts. So that's 2/6, 2 out of 6 parts. Totally 6 parts. 2 out of 6 represent 1/3. So in other words, this 1/3 equivalent to 2/6. Now replace half by 3/6. Replace 1/3 by 2/6. Now, can you tell which one is bigger, which one is smaller? Apparently, the first one is bigger, right? But the first one equivalent to half. So half is bigger than 1/3. So what is a takeaway point? Takeaway point is that first, we don't need to draw this. That's just for teaching purpose. The conclusion is that in order to compare two fractions easily, which one is bigger, which one is smaller, we want to have same denominator. In other words, we convert each fraction to their equivalent with the same denominator. Then we just need to compare the numerators. Easy to do. Okay, now we are going to do some examples. A common denominator is a common multiple of the denominators. Common multiple of not just given number, common multiple of denominators between these two. Common multiple of these two numbers, not the other number on the top. Okay, common multiple of the denominators. Now we need to compare, insert one of these three in here. Now, first we need a common denominator because they are not the same. Now you can see it's hard to compare directly, right? We need a common denominator. Common denominator, just these two multiplied together, 56. Now, 5/8 equals, we need 56 on the bottom. 8 times 7 equal to 56. Again, if you don't know, using 56 divided by that. So both sides have to multiply by 7, right? Same number. This is 35. How about the other one? 4/7 here. We need this to have 56 also, but this time we need to multiply by 8 on both sides. This is 32. Now both numbers have same denominator. Which one is bigger on the top? 35 is bigger, right? So our conclusion is that 5/8 is greater than 4/7. Actually, there's a way easier way to do that. Let's redo that so that we can do the rest faster. Say how I get this 35. Eventually, they both have the same number on the bottom. That's not a concern. We want to know what numbers on the top. That's our goal, right? How do I get 35? We use 5 times 7. Where we get 7? Look at that. 5 times 7 times the denominator of the other fraction. How do I get 32? 4 times 8. How do I get 8? This times the denominator of the other fraction. Just cross multiplication, in other words. So 5 times 7 is 35. 4 times 8, 32. Which one is bigger? Super easy, right? Okay, now I'm going to do the rest 2 examples that way. So first, 7 times 11 is 77, okay, on the top. 9 times 8, 72. And the result is the denominator is still need to write denominator to have complete answer. Okay, 8 times 11, 88. 88. Both are negative numbers. So between negative 77 and negative 72, which one is bigger? Remember, for negative numbers, the bigger the size, the smaller the value. So this one is bigger in value. This is smaller in value. So we insert it in here. Okay. Now we need to convert this to, actually, if you don't have improper, if you don't have improper fraction at the fractional part, we only need to compare the fractional part because whole number part is the same. We don't need to compare them. So 5 times 9, 45. 7 times 6, 42. 45 is bigger than 42 for sure, right? So this number is bigger than that. How fast, right? Easy to do. And if you're not sure, you can convert each one to improper fraction first. Say 4 and 5, 6 equals 6 times 4, 24, plus 5, 29 over 6. The other one is 4, 7, 9, 4 times 9, 36, plus 7, 43. Now you compare these two. So 29 over 6 and 43 over 9. Do cross multiplication, but this time I'm going to use a calculator. 29 times 9, 261. And 43 times 6, 258. You see, the conclusion is the same. Still, the first number is bigger than the second one. This is our first number. This is the second number. But this way, only look at the fractional part is way easier. But there's a condition for you to do that. These two numbers have to be the same, and the fractional part have to be improper fraction. I take it back. Have to be proper fraction. If improper fraction, you have this part bigger than 1, you have to convert it to a standard mixed number. Okay, this is the last side of exercise problems for this video. Basically, that's all. See you in the next video.